Bismillahirrahmanirrahim. Now we'll continue. We'll finish the examples. Now we'll go to the questions from the old exams. Well, I think it will be easier so that he will ask you about specific things. I have A is a matrix. He wants the diagonalization matrix B. Okay. That B inverse AB is diagonal. You need to be careful here. Yeah. We have A equal BD B inverse. Yeah. We have A equal PD B inverse. So you want this to be diagonal, B inverse AB, multiply by B inverse from this side and by B from this side. I have B inverse A, that will be B inverse times B, which is I, B inverse. Now multiply P from this side. So I have B inverse AB equal D. So I'm doing the same thing. It's P, not B inverse. Okay. So I'll find the eigenvalues and eigenvectors. So let me find the eigenvalues. That will be 9 minus lambda minus 8, 6 minus 5 minus lambda. That will be what? Lambda square. 5 lambda minus 9 lambda minus 4 lambda minus 45 plus 48. That give me what? Lambda square minus 48 minus 4 lambda plus 3. And this is what? Lambda minus 3 times lambda minus 1 equals 0. So lambda equal 3 or lambda equal 1. The 1 lambda 2. Now we'll come for lambda 1 equal 3. I need to find the eigenvectors. For sure, A is diagonalizable. Huh? A is diagonalizable, very clear. Since you have distinct real roots. Okay. Well, lambda 1 equal, I let V1 to be K1, K2. Let me see what will happen. I have what? 6 minus 8, 6 minus 8 times K1, K2. That equals 0, 0. So what I have 6K1 minus 8K2, the same. So it means K1 will be 8 over 6, 4 over 3 K2. So K2 is free. Let K2 equal 1. Let K2 equal 3. I don't need fractions. So K1 equal 4. So my V1 will be 4 and 3. Okay. Now for lambda 1, for lambda 2 equal 1. What will happen? I let V2 now to be K1, K2. I'm getting what? 8 minus 8, 6 minus 6. So I'm getting 8K1 minus 8K2 equals 0. And the same thing, 6K1 minus 6K2 equals 0. Very clear, I'm getting K1 equal K2. So I let K2 to be 1. So I'm getting K1 is equal to 1. So what is my V2? 1, 1. Now he said they wanted to be the diagonal. So there is no problem. I put now. Now if I put V1 like what I'm doing, 4, 3, 1, 1. This is my P. What will be my D? It will be 3, 1, 0, 0, which is diagonal. And also, I can put P the other way. I'll put this and this one, 1, 1, and this is 4, 3. But my D in this case will be 1, 3, 0, 0. Both will give me a diagonal matrix. And this will be the answer. And this is the correct one. This one is not. This one is not. I don't have 2 and 5, 1 and 3. I don't have all of this. So there is not only one solution, there are many solutions, but be sure it should satisfy the. Actually, any scalar multiple of this is also an eigenvector. Same thing. I need B inverse AB is diagonal. So let me do the calculation. Yeah, I will do A minus lambda I. That give me what? 5 minus lambda minus 3, 2. This is minus lambda. So I have lambda square minus 5 lambda plus 6. And that give me lambda minus 2 times lambda minus 3 equals 0. So I have lambda equal 2 and 3. So for sure A is diagonal. Now let me do lambda 1 equal to. What will happen? I let V1 will be K1, K2. So do the calculation. I have 5 minus, that will be 3 minus 3, 2 and minus 2 times K1, K2 equals 0, 0. So I have 3K1 minus 3K2 equals 0 and 2K1 minus 2K2 equals 0. So for sure I have K1 equal K2. Let K2 equal 1. I'm getting K1 equal 1. So it is my V is 1, 1. Or unscalar multiple of this. Okay. Now let me do the other one. For lambda equal 3, I let V2 to be K1, K2. That give me what? 2 minus 3, 2 minus 3 times K1, K2 equals 0, 0. So I have what? 2K1 minus 3K2 equals 0. In other words, I have 2K1, or let me say K1 right away, equals 3 over 2K2. So I let K2 to be 2. I'm getting K1 equals 3. So I have V2, 3 and 2. I don't have that. I have this is 1, 1, but this is 3, 2, 3, 1. So this is wrong. This is wrong for sure. But this is the matrix D. I'm not looking for D, I'm looking for. This is 1, 1, this is 3, 2, this is wrong. Yeah, be careful. V1, the eigenvector can be any scalar multiple of this. So V1 also, I can make it multiply by minus 1, minus 1, minus 1, like what he did here. Or minus 2, 2. Minus 2 to 2 is also acceptable. But this is 2, 3, not 3, 2. So this is wrong. Also V2, I can multiply it by a constant. I think I multiplied by 3. So I have 9, 6. So this is correct. This is correct. So my P can be 1, 1, 3, 2. Or it can be minus 1, minus 1, 9, 6, like the way he did. So be careful about the answers. Suppose that a 2 by 2 matrix has the eigenvalues this, and their corresponding eigenvectors are this. If A squared equal this, find X plus Y plus Z plus W. I don't have A. Okay. What I have? I have A equal PD B inverse. I have A. Now be careful about this question. I have A equal PD B inverse, where D is a diagonal. It has just the eigenvalues 2, 1, 0, 0. And what is P? It has just the eigenvectors 2, 1, 3, 2. Yeah, actually, I can do it in two ways. You can find A. I can find A easily. Yeah, I have P. I need P inverse. I can't find P inverse. What will be P inverse? I need the determinant of B. You know how to find P inverse. Determinant of B will be 4 minus 3. That is 1. So P inverse will be what? Change this and change the sign of this one over 1. So it will be. So that will be P inverse. So I have P inverse. So now to find A squared, I have two ways. One way, I can say A. I can find A. I know B. I know D. I know B inverse. Do the multiplication, find A. Then square it. Then find A square. Maybe this is a little bit lengthy. Another way, if you think about A square is what? A square is A times A. A times A. And what is A? Is PD B inverse. And the other A, PD B inverse. What is this? This is I. So this is actually P D squared B inverse. To square a diagonal matrix, you just square the diagonals. So D square is there. So from here, D square will be 4001. So I have only two products. In this case, I have 1, 2 products and third one when I find A square. So I save one product. So let me say A square will be P, which is what? 2, 3, 1, 2, times D square, which is 4001, times B inverse. Now do the calculation. Do this times this. Easy. 1 times the diagonal. So it will be easy. That will be 8. And this will be 3. That will be 4. And this will be 2. Times this. Let me see what will be the answer. This one times this. 16 minus 3. That will be 13. That will be minus 24 plus 6. That will be minus 18. 8 minus 2. That will be 6. Minus 12. Minus 12 plus 4. That will be minus 8. So it will be x plus y plus z plus w. That will be 13 minus 18 plus 6 minus 8. That will be minus 5 minus 2, which is minus 7. And that will be the answer. I think it's a good one. Okay. Same thing. He gave you 2 by 2 matrix. Gonna have the eigenvalues this and these eigenvectors. Find A square. The same idea. What is D? 1, 0, 0, 2. What is P? 1, 1, 4, 3. I need B inverse. I need to find B inverse. Yeah, I need to find the determinant of B. That will be 3 minus 4. That will be minus 1. So B inverse will be minus 1 times this 3 and 1. Just change it. That give me minus 3, 4, 1 minus 1. That will be B inverse. A squared is what? P D squared B inverse. And what is D square? Easily 1004. Just square the diagonal. So it's a diagonal matrix. So that will be 1143 times 1004 times minus 341 minus 1. Hopefully I did not do a mistake the calculation. Okay. So I have 1. That will be 16. that is 1, that is 12 times this. So I have what? Minus 3 plus 16, that will be 13. 4 minus 16, that's minus 12. Minus 3 plus 12, that is 9. 4 minus 12, that is minus 8. So it will be x plus y plus z plus w. That will be 13 minus 12 plus 9 minus 8. This is 1, this is 1, so it's 2. So this is my answer. Let A be, this determine whether or not the given matrix is diagonalizable. If it is, find B and D. Okay, very clear. So I need to find the eigenvalues. That will be 1 minus lambda 2, 5, 4 minus lambda. I have lambda square minus 5 lambda plus 4 minus 10. So I have lambda minus 6 times lambda plus 1 equals 0. So lambda equals 6 or lambda equal minus 1. Is lambda 2. Now for lambda equals 6, what I'm getting? Do the system. I let P1 will be K1, K2. I'm getting what? This will be what? Minus 5, 2. 5 minus 2. K1, K2 equals 0, 0. It's the same equation, by the way. Easily to see, huh? 5K1 minus 2K2. By multiply by minus, you get the second one. So what will be that? So I have K1 equal 2 over 5K2. So I let K2 to be 5. K1 will be 2. So my V1 will be 5 and 2. This is 2. Now for lambda equal minus 1, what I'm getting? I let V2 to be K1, K2. So it will be the system. 2, 2, 5, 5. So very clear, I have 2K1 plus 2K2 equals 0. And 5, it's the same one. So I have that K2 equal minus K1. So I let K1 to be 1. I'm getting K2 is minus 1. So my V2 is what? 1 and minus 1. So what is D? D will be 6 minus 1. These are zeros. P, I have the corresponding eigenvectors. For 6, I have 5 and 2. For minus 1, I have 1 and minus 1. Which is this answer? Okay. Let A be this diagonalizable matrix. Okay. Let A be a diagonalizable matrix. You want me to find D and B, roughly. You want me to find B and D. Do the calculation now. So I have determinant of A minus lambda I. That give me what? 1 minus lambda 0, 1. 1 minus lambda 0, 0, 0. 2 minus lambda. So very clear that will be 1 minus lambda square, 2 minus lambda equals 0. So the eigenvalues will be 1, 1, 2. Now let me do lambda equal 1. Yeah, he started with 1. Okay, I'll do this. So I let V1, K1, K2, K3. And I need to do the calculation. So I have the system 0, 0, 1, 0, 0, 0, 0, 0, 1 times K1, K2, K3 equal 0, 0, 0. Yeah, by the way, this is wrong, huh? Because the diagonal 1, 1 minus 1, I have 1, 1, 2. Okay. I look like this. Okay. So I have what in this system? K3 equals 0. So I have K1 and K2 are free. So I do the usual trick. I have let K1 equal 1 and K2 equal 0 and K1 equal 0 and K2 equal 1. K3 is fixed 0. So I have here V1, it's 1, 0, 0. And I have V2, it's 0, 1, 0. So this is okay. This is wrong. Cannot be. This will not work. This one okay. Yeah. But depends on the last one. This one is okay. This one is wrong. Okay. Now I will work out for lambda equal to, let me see what will happen. I let V3 to be K1, K2, K3. What will happen? I have this system minus 1, 0, 1, 0 minus 1, 0, 0, 0, 0. So I have what? Minus K1 plus K3 equals 0, and I have minus K2 equals 0. So I have K2 equals 0, and K1 equal K3. I let K3 equal 1, so K1 will be 1. K3 will be the free variable. So what is V3? It will be 1, 0, 1. So what is my D, and what is my P? D, let me write it here. D will be 1, 1, 2. The rest are zeros. This is the diagonal. And what is P? The eigenvectors. I have the eigenvectors 1, 0, 0, 0, 1, 0. And the last one is what? 1, 0, 1. So this is my answer. Okay. This one I think we did. No, we did something similar. Okay. A B is the diagonalization matrix 2 by 2. It's easy. Okay, let me do it. I need to find. P. Okay. So I will do 2 minus lambda, the eigenvalues. Then I will find the eigenvectors. That will be 2 minus lambda square plus 1, minus 1, sorry. That will be lambda square minus 4 lambda plus 3. And that will be lambda minus 3 times lambda minus 1 equals 0, which is good. So I have lambda equal 1 or lambda equal 3. I know the order. Let me see. So yeah, it should be lambda equal 1, the first one. So for lambda 1 equal 1, I let V1 will be K1, K2. The order is important. This is 1, this should be V1, the one with the Y, with lambda 1 equal 1. So I have the system 1, 1, 1, 1 times K1, K2 equals 0, 0. So I'm having K1 plus K2 equals 0. So K2, or let me say K1 equal minus K2. So I let K2 to be 1. I'm getting K1 is minus 1. So V1 will be what? Minus 1, 1. This is not wrong. This is not correct. Now for lambda 1 equal 3. 3? Yes. What I have? I let V2 to be K1, K2. So what is the system? Minus 1, 1, 1, minus 1, which is easy one. Very clear. I have K1 equal K2. Let me do it in details. Minus K1 plus K2 equals 0, and K1 minus K2 equals 0, which is very clear. I have K1 equal K2. So I let K2 equal 1. I'm getting K1 equal 1. So what is V2? 1, 1. So what is my P? My D is this 1003, and my P is minus 1111, and that is the answer. Okay. Last one. Same thing. He wanted me to find D and P. Okay. So I find the eigenvalues. That will be what? 5 minus lambda minus 3, 2 minus lambda. Did I do this? 5 minus 3 to 0 before? Yeah, we did this. This is my P. Let me do it again since the last one. I have what? Lambda square minus 5 lambda plus 6. So it's lambda minus 2, lambda minus 3 equals 0. So I have lambda 1 is equal to 2, and lambda 2 equal to 3. So I have 2, 3, 2. This is wrong. The rest are okay. So now for lambda 1 equal to, I'll need to find the eigenvalues. I let 1 to be K1, K2. So to the system, it will be 3 minus 3, 2 minus 2, K1, K2. So I have 3K1 minus 3K2 equals 0. 2K1 minus 2K2 equals 0. So you have K1 equal K2. That means let K2 equal 1. I'm getting K1 equal 1. So V1 will be 1, 1. This is wrong. This is wrong. This is wrong. Should be the same. Either 1, 1, 2, 2, 3, 3. Okay. So these are the possibility. Now for lambda 2 equals what? 3. I let V2 to be K1, K2. What I will get? I get what? The system will be what? Lambda 2 equals 3. That will be 2 minus 3. 2 minus 3. I'm only one equation. 2K1 minus 3K2 equals 0. In other words, K1 is 3 over 2K2. So I let K2 to be 2. So K1 will be 3. So it is V2 is 3, 2. So it is my D. D will be 2003. And P will be what? 1132. Yeah, which is this one. Now I have questions from the book. I think I will stop. I think it's enough. We did, yeah, all of these, all the exams questions related to this section. And then we'll go later with the questions from the book. Let me stop the recording. Thank you.